little bit about the nameplate configuration on electric motors. You'll see something like this on an electric motor, and you'll see besides the manufacturer's name that will typically be across the top or along the side, you'll see a spec number. Spec number only indicates the number that the manufacturer assigns it, and it has more meaning to the manufacturer than it does us. The information that we're most interested in is when we get down here to the lower sections where we have FR, which is short for frame. The frame size, it'll be different on almost every motor. 184T is an indication of the size of the shaft as well as the footprint of the motor, the bolt pattern of the motor, and it also tells us what size shaft. And so that's helpful information if we have to replace it. Obviously the horsepower is important. And then we have voltage indication. Voltage indication may change. Here on this example is a 208/230 /460. These voltage and amperage lines, they work together in that the amperage will tell you at a specific voltage what that amperage draw will be. For example, you can kind of see the similarity in the format here. We have 208-230/460 28-26/13, which means that at 208 volts at full load it's going to pull 28 amps. At 230 volts at full load it'll be 26 amps, and at 460 volts it'll pull 13 amps. The fact that this is 208-230/460 indicates that there's two different wiring schematics, that it'll be wired one way for 460 and it'll be wired another way for 208-230, which means that if it had a wiring schematic that indicated low voltage, then your low voltage is your 208-230. And so the wiring is the same whether it's 208 or whether it's 230. If you had a wiring diagram that indicated high voltage wiring, then it would be the wiring for 460 volts. A motor with this type of number on it means that it can run on either 208 or 230. You may also see at some point in time where you'll see under the voltage it may say 230/460, and you won't have that 208 designation. And then you're going to have below it for amps, you'll have your 26 and your 13. Means the same thing, just that this motor is not wired or built to be able to run also on 208. It's only going to run properly on 230. It may run on 208, but it won't run properly. It'll only run properly on 230 volts. So this kind of stuff is really important as we do our routine scheduled maintenance, to be able to identify what our actual voltage is, whether we're dealing with 208 or 230, because these are the amperage numbers that we're looking for. In terms of RPM, you're going to see 1725. In some cases, you're going to see 3450. 3450 is real common on air compressors. They're high-speed motors. They get a lot of their power from torque and speed. 1725 motors, RPM motors, are more, you'll see in a commercial application, industrial commercial application. They're a better quality motor. They're built heavier, and they're really what we're looking for in using for our pressure washers. Hertz is a 60 hertz. That's what we see in the United States. In Europe, you'll see a 50 hertz. So this is pretty much everything we'll see in the United States. pH stands for phase, single phase or three phase. That's covered in another training video. And then class, a lot of times will have to do with the insulation class, how well the motor is insulated, what kind of insulation it uses. That really doesn't have a whole lot of significance for the purpose of this training video. SF is also something that's real important too. SF stands for service factor. Service factor, you're going to see either 1.0 or 1.15. On a cheap motor, you're going to see it as a 1.0. Or on a motor that is actually being used to its absolute maximum potential. What this means is that typically on an industrial motor, you're going to see it 1725 RPM, and you'll see a service factor of 1.15. That means that at whatever the nameplate horsepower is, the manufacturer has built in an extra 15% capacity, just as a little fudge factor, just as a little bit of wiggle room. We don't utilize that in setting that up. We utilize these numbers, which is all what they ask us to do, but we can, in certain situations, use that 15% and that means that we can actually exceed our amperage by 15%, and we're not going to destroy the motor. The motor's going to be okay. On some motors it's 1.0, which means that under no circumstances can we exceed these amperage figures. And then sometimes what you'll see is that normally on motor horsepowers, a standard horsepower is a 3, a 5, a 7.5, and a 10. Once in a while you're going to run across some odd numbers that aren't like these, a 3, 5, 7.5, or 10. These are industry standards across a lot of different, not just pressure washers, but a lot of different pieces of equipment. You might see a 6. Typically what that means is that they've taken that 1.15, they've taken that extra 15%, and they boosted it up automatically, which means that now this motor, whereas a 5 horsepower might have a service factor of 1.15, the 6 horsepower is only going to have a service factor of 1.0, because they've used this 15% in order to get the 6 horsepower out of the exact same motor. So now it's a 1.0. You'll see the same thing with other manufacturers, where instead of a 7.5 it'll be an 8. Whereas a 7.5 will have a 1.15 service factor, which means there's a 15% margin there that we can creep up on. This 8 horsepower will say a 1.0. What that's telling me is that what you actually have is a 7.5 horsepower motor. In actuality, that is just being worked to its absolute limits. A 6 horsepower is really nothing more than a 5 horsepower that's being worked to its absolute maximum capability. So this is kind of an overview of a nameplate. If we have a bad motor out in the field, these are the numbers that we need to have. We need to have the model number, or the manufacturer's name, the spec number if you can read it, but what's most important is your frame size, the horsepower, the voltage, the amperage, and the RPMs. Those are the absolute most. We need at least those 5. Anything else that we can get is always going to be helpful, but we've got to at least get those 5. If you have any questions, check with your supervisor or visit us on the web at www.aefresno.com.